Alright, in this section here, we're going to be going over find the slope of the tangent line at a given point. So this will be much like this first section here, finding the derivative by the limit process, because we'll still be doing that, except we're going to add something a little extra onto this. So find the slope of the tangent line. Let's scroll on down the screen. But the first thing we're going to do is we're going to bring up a picture. I can find a picture here to bring up. Yes, I believe this is the picture here. Okay, so you should be able to see this. All right. This is this red line right here, as you can see. This is going to be the graph of the function that we're going to be looking at, and that is just I believe that's going to be x plus 1. Yeah. So you see the red dot here that I'm following, and just up and to the left of the red dot, you see this d over dx. And what that actually is, it's some different notation we haven't talked about yet. And that's actually going to be the slope, which, as you can see, is equal to 1. That's the slope of this line. Now, and you can see x is equal to 1.47, 1.09. And we're going to be actually looking at the point 1, 2, so this point right here. And we're going to be asked to find what is the slope of the tangent line at the point on the graph at 1, 2. Now, I don't know if you can see this or not, but notice that the line is actually black. The line's red, but there's this black part of the line, as you can see here. That is the tangent line. Okay, and it's hard to see because this is just a line. Yeah. Okay, well, let's just get over here and find the slope of that line. Okay, so the first thing we're going to do is we'll go ahead and write out and I think we're going to call the function, let's see, we'll call it m. How's that? And I think probably what I need to do here is let's use capital M. So m of x is equal to x plus 1. And what we're going to want to do is find, we're going to want to find m prime of x. All right, so just like in the previous section, we're going to be finding the derivative, and we're going to be using the definition of the derivative, the limit. All right, so we got to remember what that is. Okay, got to remember what that is and write this in. So I don't know, what did we use? We used delta x last time. I think that's probably what I'll use again. All right, so we'll just write this out. Delta x is going to 0. All right. So you should have this. Memorized by now. I know I do. All right. No, that was a minus. What? F of x. All right, and it's all over. What's it over? It's all over delta x. Okay. And so this is what we want to find here. Now, we're finding the slope of a line. And do you remember that? That's m is equal to, and then I'm just going to write it like this, y2 minus y1 over x2 minus x of 1. Okay, this should look familiar. to you. This is just finding the slope of the line given 2 points. Well, if you take a look at this up here, see this up here? This pretty much is this. It's the change in y over the change in x. Okay, so I thought I would just throw that at you. All right. Okay, so the first thing we're going to want to do here is we need to find this guy right here, f of. Let me go ahead and just highlight this. Oh, that's right. It doesn't let me do that. I don't know. Let me try it anyway. Maybe it will. It did. Okay. All right, so we're taking x plus delta x and we're plugging it in to this right here. And I noticed there's something that I left off. We'll talk about it here in just a second. Let me go ahead and finish this. All right, so we're plugging it in. Right, so this x gets replaced with whatever's in parentheses here. Okay, and then we got plus 1. Plus 1. All right. Okay, let me go back to this graph here real quick. Well, that's not what I wanted to go back to. We're going to be at the point 1, 2, which is about right there. All right. However, I didn't mention that up here. So let me go ahead and mention that. 0.12. Okay. All right. So we're going to need to know that. All right, so we're going to be wanting to find, we got to find m prime of x first. And once we find m prime of x, and then what we're going to do is, go ahead and we're going to be looking for m prime of 1. Okay, so this is what we're really after right here. I should probably write that down here, but okay. What are we doing here? I forgot what's going on. All right, so we found this up here, and we already know what that is. That's just x plus 1. So we just go ahead and plug everything in. That's what we need to do. Just plug everything in. So we'll just rewrite that. Okay, let's go ahead and rid of the top there. So we got x plus delta x plus 1. Okay, that's this part right here. And then we have minus. Now remember, don't forget, you have to put parentheses around this because of that minus sign. If you don't, you're going to end up messing this thing up. Okay, now what we'll want to do is simplify this guy. And yeah, we'll just rewrite it. Okay, and since we got plenty of screen, we've got plenty of screen over here. What we could do is I could just write equals and do that. All right. And let's now simplify this numerator. So as you can see here, we're going to go ahead and remove that. We have the minus, but we're going to need to distribute that minus across. Okay. All right, so as you can see here, we have an x and a minus x and a plus 1 and a minus 1. So what's going to happen here? Well, they're all going to just disappear, and a delta x over delta x just becomes 1. And so that all just became 1, which is equal to
1.
So as you can see here, the limit as delta x approaches 0 of 1 is just 1. The limit of a constant is just the constant. So we can come up over here and say then that m prime of x is equal to 1. So no matter what you plug in here for x, it's still going to be equal to 1. Doesn't matter. For all numbers x, this is going to always be equal to 1. So as you can see here, that m prime of 1 is just 1. M prime of 1 is 1. And when we go back to our graph, right, so that would be this point right here, 1, 2. The point, 1, 2. See that? But you see this d over dx? That's 1. But remember what I said, no matter what number you plug in for x, it's still going to be, as you can see that number right there, it's still going to be 1. Okay, so it ends up becoming basically the slope of the line, the slope of this line. All right. Pretty simple. Okay. All right, let's look at another one. All right, so as you can see here, yeah, at the point 1, 2. So it doesn't matter. It could be at any point on the line. It's still going to be 1. The slope is still going to be 1. And this will become more clear here in a couple more problems.
1.
All right, let's look at another one here. We'll call this one R. Why not? We'll say R of x is equal to 2x minus 1. And we're going to be trying to find, well, we are going to find the slope of the tangent line at the given point 0, negative 1. And so I'm going to go ahead and go on down to the next one. All right. And we're going to be looking for R prime of 0. R prime of 0. Okay. So the first thing we need to do, though, is we need to find R prime. Right. And we're going to be using a little formula here for finding that. So the first thing we want to do is find f of x plus delta x. Now, if you want, you can put an r in right here. Okay. So you don't get this confused because we are looking for r. We'll just do that. What's that? So you don't get confused on that. Okay. All right. So let's find r of x plus delta x. So that's what we want to find first. And we'll just copy and paste this. Wish I'd have known that in that last section I just did. Okay, so x plus delta x is going to get plugged in. All right, and it's just and we have minus 1. All right, so we'll want to simplify this, and that's going to be 2x plus, okay, we're in caps here, 2x plus 2x plus delta x, copy that, 2x plus delta x minus 1. And actually, what I was wanting to do is distribute that across. Okay. All right, so let's go ahead and go ahead and rewrite our limit. Okay, and we can now, alright, so this part right here is going to be the 2x plus 2 delta x. I don't know what that little line is doing down there. Little red line showed up. I don't know. Okay, so we have 2x plus 2 delta x minus 1. And then, of course, r of x is just 2x. See what I almost forgot? 2x minus 1. Okay, so we need to go through now, right? We can drop that, and we need to change that to a plus because we're multiplying across by -1 more or less. And as you can see here now, I guess probably what I should do is just go ahead and equals, go ahead and bring this over. Okay. And so let's go ahead and let's see. So we have a 2x, as you can see here. We have a 2x and then minus 2x, so those are going to go away. And of course we have a -1 and a +1, those are going to go away. And that 2x disappears. And now we have a delta x over delta x, which that can be reduced to 1. And so we end up being left with on this 2. Okay, 2. All right. So up here, actually, I think what I'm going to do here is just go ahead and so the derivative is 2. And no matter what you plug in for x here, you can see that you're always going to get 2 out. So r sub 0 is going to be 2. Right? You see that? R sub 0 is going to be 2. And I think we have a little bit of time left. And so let's take a look at this. This is 2x minus 1. Hopefully we got some time. I don't know how much time we got, but okay, 2x, what did I say? 2x minus 1. Okay, hopefully we can do this. Some time. Okay, this is the graph 2x minus 1, and we're at the point 0, -1, which is right here, and you can see that the derivative is obviously 2. Okay, the derivative is 2. And there's the derivative is 2 at 0, -1. All right. Okay. So there you go. Okay, we are working on, it's like problem number 3 of this section here of finding the slope of the tangent line at a given point. We're going to call our function something else this time. Let's call it g. How's that? Let's call it g. And this time we're going to do x squared. You'll see a little better now of what we're talking about on this tangent line. And we're going to be looking at the point 1, 1. So we're not going to be going too far out into the universe. And first thing we want to find is g prime of x. So you should be familiar with this now. And then we're going to plug in 1. Right, that's this 1 right here. That's your x coordinate. I'm going to plug that in, that we're going to find that, and that's going to give us the slope of the tangent line. And so you don't get too confused here, we'll go ahead and change these up. think what we'll do now is we'll just bring up a picture. Let's bring up a picture here. I guess I should notice, or I should note that here we're using this graphing calculator I got from the web Chrome store, Mr. Technology it says. So I like it because it gives us the tangent line and the slope of the tangent line at the given point. Okay, so this is the graph of x squared here. Now, you see this black line here, looks like some kind of toothpick or something. That's your tangent line. Okay, that's the tangent line. And as you can see, that d over dx, which is 1.7 in this particular case, that's the slope of that tangent line at that given point. It looks like x is equal to 0.85. All right. What about right here? This is where the slope is 0. This is actually an important concept here. This is known as the minimum, finding the minimum. We'll talk about that later on in the story. All right. So that's what we're doing, and actually we're going to be at the point 0, -1. 0, wait a minute, how could this be? No, we're at the point 1, 1. Never mind, I wrote down the point 1, 1, which is right about there. So at the point 1, 1, the slope should be, I mean, I know what the slope should be, but yeah, that's about right. Okay, let's get back over and get started. We got to get started here. All right, so we're looking for g prime of x. We're going to be using our the definition here of the limit, provided the limit exists. First thing we're going to be doing is we're going to be looking for this. Got to get that. Right. Now I'm going to be skipping some algebra steps here. We don't want to get caught up in all that. Okay. So x plus delta x goes in right in there. X plus delta x. So right, and remember that is going to be squared. It's going to be squared. Okay, so what we'll need to do here is we're going to need to multiply this thing out. All right, x times x is x squared. Like I said, I already went over this in the last section. Plus 2x, and then copy that. 2x delta x plus, and I'm putting parentheses around this, delta x squared. All right, this is what we get when we multiply that out. Okay. No, let's not do that yet. Okay, so I'm going to go ahead and rewrite this, rewrite the limit. Go ahead and rewrite the limit. Right, and now we'll go up here in the denominator. Because we're going to want to substitute that in right here. Whoops, I went way too far. Hopefully I can reverse that. Yeah, there we go. Got crazy there for a second. It's getting crazy, man. Okay, and of course g of x is what? X squared. All right. And I think what we'll do next here is just rewrite all this. If you don't mind. And of course we need to gotta put an equal sign in here. We're gonna, doesn't make any sense. All right, we have x squared and we have a minus x squared. See this? So those guys are gonna they're going to cancel out. Let's just go ahead and do that. And right, so this did it again. The function always subtracts out. All right, always subtract out the function. Now I want you to look at this. We have a delta x here and 2 delta x's here, and we have 1 down here. So we're going to be able to cancel 1 out up here and 1 out right here. Okay, so let's actually write this out again. All right, might as well, we'll just continue it on the same line. Sounds good. Okay, so we're going to end up with a 2x plus a delta x. 2x plus a delta x. Hit the wrong key on that one. Alright, 2x plus delta x. And now we go ahead and do our direct substitution, plugging 0 in right here for delta x. And we're going to end up with, I think I'll just continue this on the next line. So we're going to end up with, and I'm just going to go ahead and write an equal sign here. Okay, we're going to end up with 2x. All right, see that? It would be 2x plus 0. Doing the direct substitution, plugging 0 now directly in. We have 2x plus 0, but we don't need to write that. Okay. All right, so let's go back up here. So we know that the derivative is 2x, and now we're going to plug in 1 into the function, right? And that is going to be equal to 2. See that? So the slope of the tangent line at 1, 1 is 2. Let's go back and look at this real quick. So we were at 1, 1, okay, and I'm going to try to get as close as I can here, but it doesn't look like the cursor's not going to really let me now. Anyway, but you can see here as I get to, yeah, it skips over it. Can't get that. Anyway, you can see here what the slope of the tangent line is. Okay, so that's how to find the slope of the tangent line. All right, I think this was problem number 3. So we got a couple more to go. All right, see you in the next problem.
One.
All right, in this problem here, we're going to have 3x squared plus 1. So let's go ahead and write that in. 3x squared plus 1. And we're going to be at the point 0, 1. Of course, we'll look at the graph here in just a second so you can get an idea what the picture is. And you know what? Let's name this function L. Yeah, why not? We'll name it L. Go here, change a few of these. Just showing you that you can name your function anything you want. Okay, let's, so we're going to have to find the derivative first. And then once we plug the derivative, or once we get the derivative, then we're going to plug in 0, the x-coordinate, to find out what the slope of the tangent line is at the point 0, 1. Let's go up and look at the graph and see what we've got on here. So this is the graph here of 3x squared plus 1. And here's the point. See if we can get it exact here. Well, I had it. Gosh darn it. Oh, there it is. So there's the point. You can see there x is equal to 0, and that d over dx is equal to 0, and that actually represents the slope. So as you can see that the slope of the line is 0, and notice that that line is actually parallel to the x-axis. Right, it's a horizontal line. All right. Okay, well, let's go up here and start working this thing out. Okay, so the first thing we want to find is this part right here. Okay, is equal to, so we're going to have 3, or not 3, not 2. And then x plus delta x. Put an extra space in there. Oh no, what happened? That's nice. Yeah, that ended up, okay. Did it again. I did it again. Okay, is there a way that I can get rid of that? Alright. Okay, try that again. And of course this is squared. And then we have plus 1. So we're going to want to we're going to need to multiply this thing out here. So we have x times x is x squared, and I'm going to skip some steps on this, so hopefully you can keep up. While I'm multiplying this thing, I'm going to go ahead and distribute this 3 across. You don't distribute the 3 across yet because this is squared, but I'm going to multiply this out in my head and then multiply the 3 across. Okay, so we have 3x squared. The next term would be 2x delta x, and then that 2 times 3 is 6. So 6x delta x. So hopefully you're able to keep up with me on this, and hopefully I don't make any mistakes. Alright, and then we have plus 3. Okay. Alright, so that takes care of that piece right there. So we're pretty much good to go on that. So let's go ahead and write this stuff in up here. Alright, so that's that part. And then we have minus. Now remember, because of that minus sign, we've got to distribute that minus. But what we're going to do here is we're going to go ahead and start a parentheses. Helps us not to forget. 3x squared plus 1. Right. And I think what I'll do here is we'll just go ahead and copy all that. Oh. And then write it in. Alright, so up here, oops. Okay, so as you can see here, we're going to distribute this negative across. We're going to knock those guys down. That's going to make that a negative. And get rid of that. And now we need to simplify this. We need to simplify this down. We'll do that on the next line. And I guess I should write an equal sign right here. I don't know if I've been doing that or not, but just showing you that this is equal to the previous line. Okay, so you see here we have a 3x squared and a minus 3x squared. And we know those are going to cancel out. And something is fishy in St. Louis here. I'm trying to figure out what it is. Oh, I see what it is. So you might have been screaming at me. There should have been a +1 right here on the end, because this is all of this piece here, then the +1. So I forgot the +1. That's okay. We'll go ahead and add it in. Of course, we could simplify that a little bit. Would make that a 4, but let me just go ahead and write it in right there, okay? And +1. Okay. We'll go ahead and do that, all right? So we have a +1 and of course a -1. So we're going to go ahead and get rid of those, and that negative 3x squared, that positive 3x squared up front, those are going to go away also. And so let's go ahead and get rid of them. Okay. Now, something else is fishy in St. Louis. That should have been a delta x right there. And so you're probably going, why didn't you write a delta x in? Yep. I just woke up not too long ago. That's probably half of this. Okay, so let's get over here. It's okay, no problem. Now remember, we're going to go ahead and put that in parentheses. Okay. So hopefully you caught that stuff. It was probably yelling, hey, you forgot the delta x too. Alright. And where we at here? Okay. Okay, I think we're good now, except right here.
1.
Let's move the screen up so we can see something. Believe we have it. As you can see, we have a delta x here in this term, and then we have 2 delta x's here. So since we have this delta x down here in the denominator, we can go ahead and cancel out 1 up here and 1 in this term right here, and then we'll rewrite it. So let's go ahead and do that. And we'll just write it all on the same line. And if I get rid of this, yeah, we'll just, okay, so we're going to have 6x, and that delta x is going to cancel out, plus, and then we'll have the 3, and then delta x. Whoa, I didn't mean to do that. I meant to put a delta x here. Which so I've learned to use shortcut keys on everything, so I don't have to use a mouse. I don't know. It kind of helps out. What we'll do now is go ahead and do the direct substitution, taking 0 and plugging it into delta x right here, and we'll be done. So we'll have 6x plus 3 times 0, and of course 3 times 0 is just 0, so we're just left with 6x. We're left with 6x. So finally, we went up here, we found the derivative. The derivative is 6x. We can now come in here and say 6, plugging 0 in for x, and of course that gives us 0. And as you can see, that the slope of the tangent line is going to be 0 at the point 0, 1. We'll go back up to the graph and take a look at this. Right, so here's the you can see here, here's the tangent line as I toggle along here. And right here at the point 0, where x is 0, of course y is 1, but the slope of the tangent line is 0. Right. It's pretty cool. Okay. And I believe now we're going to be, we got one more. One that's a little bit more difficult, and that'll be that'll end this in this section on finding the slope of the tangent line at a point.
1.
In this problem here, we'll call it a of x, and it's going to be equal to x, well, not a capital X, x squared plus x. And we're going to be looking at this at the point -1, 0. So we're going to want to find the derivative. Then once we find that derivative, we're going to plug in the x-coordinate -1 into the derivative. We'll go ahead and put -1 here. And find what the slope of that tangent line is at the point -1, 0. So once again, the first thing we're going to want to do is find a of x plus delta x. All right, this will be the first thing. But I think what we're going to do here, before we go any further, is let's look at a picture. This was the previous problem. Let's go ahead and see what x squared looks like plus x. And all right, so here's x squared plus x, and we're going to be focusing on the point -1, 0. So as you can see here, here's -1 on the x-axis, and that would be -1, 0, and it looks to me like the slope of this line, it shows it to be 0.98 here, but because I can't get it exact, I'm going to go out on this walk the plank and say that that slope is probably going to be a -1, right? Ooh, I tell you what, it's so hot today. I wouldn't mind walking the plank as long as my arms aren't tied behind my back. All right, so the first thing we want to do is find the derivative, and that means that we're going to need to have to deal with this ombre up here. And this is probably not going to be nice, but since we're learning this for the first time, or maybe just refreshing our memory, I'm selecting some polynomials that are pretty easy. Hopefully you think they're pretty easy. Okay, so we don't spend a whole lot of time, we're just looking at the mechanics here. We don't want to get caught up in the algebra. And then of course we're going to go ahead and put in the x plus delta x here. Now you notice I didn't put a parentheses around this, whereas I always put a parentheses in right here, because of this minus sign. However, no need to put parentheses because this is a plus sign right here. Okay. So what we'll want to do now is just go ahead and multiply this out and then collect up all our like terms. So we're going to end up with x squared plus 2x delta x, and I wish there was a shortcut key for that. You can type it directly into the screen as long as it's not in an equation box, and it will come up. Let's see, but what do we have? We have x squared plus to put 2 delta x is there, and then of course this is going to be delta x squared. Alright, try not to make any mistakes this time. X plus our delta x. We need to collect up some like terms. We have an x here. You know what? There are no like terms. Wow. Okay, no like terms. Alright, let's go up here and go ahead and copy paste this bad boy. He's a bad boy. Okay. And we'll go up here. Go ahead and get rid of all that. I think what I'll do here is just go ahead and fill this in. Alright, so a of x was x squared plus x. Now remember, whoa, what's going on there? X squared plus x. I think it was being crazy. Remember, I've got these parentheses put in here now. Don't forget that. Alright. We're going to go ahead and do a little copy paste. Bam. They like that. Now, let's go ahead and drop these parentheses. Remember, we're distributing that negative across. Okay, so there we go. Now what we're going to do is go ahead and subtract off this function. As you can see, we have a positive x and a negative x. There's our negative x and our positive x, so those are going to subtract off. Something. Okay, what's going on here? What have I done wrong? For some reason, maybe I haven't done anything wrong. Okay, the negative x squared, and then of course we got one up at the very front. This x squared, those are going to subtract off, but I think probably what I should do is go ahead and just not make any changes to this one, and go ahead and rewrite it. How's that? Alright, so we have, right, so that negative x is going to go away, the x squared is going to go away. Okay, there's our x, got rid of that. And our positive x squared. Okay. Ooh. Looking here, we have a delta x, 2 delta x's, and a delta x. So since we have a delta x in the denominator, one can go into here, that'll cancel that one out. One will go into here, that'll be left with one because we have 2 of them. And 1 delta x will go into this term here, and that'll leave us with a 1. Right. So we're going to have a 2x plus our delta x, because one of them canceled out and we had to keep one because it started off with 2 delta x and then plus 1. Now we can go through and do our direct substitution. And as you can see here, we're going to have 2x plus 0. Well, that's not a 0. Plus 0 plus 1. Okay, so we're doing direct substitution. 0 goes in for delta x here, as you can see. And then, of course, we simplify that down, and we're just left with 2x plus 1. 2x plus 1. All right, so let's go up here. So we know that the derivative is 2x plus 1. And now when we go to plug in -1 into this, we're going to go ahead and do that. And then plus 1, so that's going to be equal to -2 plus 1 is -1. So as you can see, the slope of the tangent line is -1. And just like what it looks like right here, of course I can't get it exact, but you can see almost get it exact, but not quite. Anyway, you can see, you get the idea right here. See, you get the idea. Okay. All right. Well, that pretty much ends the problems in this section. And so the next section here is we're going to be writing the actual. We're going to write the equation to that line. Whoa. Keep on going up. That's what the next section is. So we're going to be going through the same steps